Hello students, in this video we are going to solve chapter 12 surface area and volume for grade 10 CBSE board. Chapter 12 surface area and volume. So these are the 3D objects we have to study in this chapter. Cylinder. These are the required formulas that we need in this chapter. Cone. This is the slant height. Slant height is equal to under root h square plus r square. If you want to find height, height is under root l square minus r square, and radius, the base radius, is equal to under root l square minus h square. Now curved surface area of cone is pi rl. Total surface area is pi r in bracket L plus R, and its volume is 1 by 3 pi r square h. Then the next solid is sphere. Surface area of sphere is 4 pi r square. Now in surface area we don't have total surface area or curved surface area because there is one single surface for whole sphere. So in other words, I can say that total surface area and CSA and the normal surface area, these three things are one and the same thing. These three solid objects we have to deal with in this chapter. And the first exercise, this is the NCERT 12.1. So first question, two cubes, each of volume 64 centimeter cube are joined end to end. Find the area of the resulting cuboid. So this is the first cube whose edge is 4 centimeter, and the another one is also identical cube 4 centimeter. So we have to find how this 4 centimeter edge is coming, because the given thing is their volume is 64 centimeter cube. Okay, so given that the volume of each cube is 64 centimeter cube, and we know that the volume of a cube is side cube, side into side into side. So let the side of one cube be x, so volume is this, x cube is equal to 64, and the cube root of 64 I can write it as 4 into 4 into 4, and cube root will send this triplet as 1 4. So 1 4, because of that triplet 4, it's going out of the cube root. So edge is 4. Now dimension of newly formed cuboid. Let's go to the diagram. If we join these two diagrams, so this length is 4 plus 4. So this length is 8, height is same, and width is 4. Okay, so there's the change in length, and height and breadth, they are 4 centimeter. We have to find surface area. The question is saying that find the surface area, find the surface area of the resulting cuboid. So here the surface area is nothing but total surface area. So it's a cuboid. Total surface area of a cuboid is 2 times in bracket LB BH plus LH. You just need to plug the numbers at the places and simplify it. You will get 160 centimeter square. Second question. A vessel is in the form of hollow sphere mounted by a hollow cylinder. So there is two shapes. One is hemisphere and one cylinder which is mounted on the hemisphere. They are sharing same circular disc or same circular circumference. So the diameter or the radius will be same. The diameter of a hemisphere is 14 centimeter and the total height of vessel is 13. Okay, so total height is 13, diameter is 14 centimeter. What we have to find? Find the inner surface area of the vessel. So there is no change. There is no difference in inner surface area or outer surface area in such questions, because they have not mentioned thickness of such object. If they are mentioning thickness, there has to be difference in inner and outer surface area. So in this question, we are not concerned with the thickness. So inner and outer surface area both are same. Total height is 13, diameter is 14. Inner surface area of vessel is equal to CSA of cylinder. So CSA of cylinder plus surface area of hemisphere. So here the surface area I mean is CSA, curved surface area of sphere. So you can write CSA also, CSA of hemisphere. Observe that the both of them is having same diameter. So radius will be 7 centimeter. Now for hemispherical part, the radius is the height of this hemispherical part. Total is 13. 13 minus 7 is the height of cylinder, that is 6. So height of only cylinder is total height minus radius of hemisphere, that is 6 centimeter. Now CSA of cylinder, let's find CSA of cylinder and CSA of hemisphere. CS of cylinder is 2 pi RH. Put the values, simplify them, you will get 264 centimeter square. So surface area of hemisphere, the formula is 2 pi r square. Put the values, simplify it, you will get 308 centimeter square. So total inner surface area of vessel is the addition of those two values. 264 plus 308 is equal to 572 centimeter square is the answer. Question number 3. A toy is in the form of a cone. It is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. So it's like similar to the previous one. Instead of cylinder, there is a cone. Total height of a toy is 15.5 centimeter. Find the total surface area of the cone. Again, we have to find CSA of cone and CSA of hemisphere. So after finding them, we will add it. Okay. Total height, base radius, we have to find TSA of a toy. Height of only conical part is the total height minus radius of the hemisphere. 15.5 minus 33.5 is 12 centimeter. This is the height of cone. Now remember that CSA of a cone is given by this formula pi r L. We don't have the value of L. We have to find L. L is slant height, and it is given by under root h square plus r square. Putting the values, h is 12, 3.5 square, 12 square is 144, plus 3.5 square is 12.25. Adding them, we get this. Now we have to solve this, okay? Do this long division to find the value of square root. You will be getting 12.5, okay? Or you can factorize them. You can factorize the value inside it. So just to make it easy, you can write it like this upon 100 and start factorizing this value. Whichever method is comfortable for you, please do it quickly and get the value 12.5 is this slant height. So once we get the slant height, we will find curved surface area of a cone, which is given by pi r L. Put the values. Observe that 3.5 is reducible by 7. So 7 cancel it. And then you have to multiply it. You will get 137. 137.5 is the CSA of cone. Now it's turn to find CSA of hemisphere. The same formula, 2 pi r square, put the values. The surface area of hemisphere is 77 centimeter square. So finally you will add those two surface areas to get the total surface area of toy. I hope this is clear. Question number 4. A cubical block of side 7 centimeter is surmounted by a hemisphere. This is a cubical block and a hemisphere is surmounted on it. What is the greatest diameter of the hemisphere we can have on the cubical block? Also find the surface area. Also find the surface area of the solid. Okay, so it's obvious that the maximum diameter available for the hemisphere that we can surmount on the cube is the edge of the cube. Okay, so let's read the solution. This is the thing I have written and given. To find largest diameter, this is my target number 1 and this is the target number 2, total surface area of the solid. So what I have written is the largest diameter of hemisphere placed on the square of edge 7 centimeter is 7 centimeter itself. The largest diameter possible is the edge of cube itself, because we cannot put a hemisphere which is going out of this cube. Okay, so the largest is touching the edges of the cube. So I guess this is clear. So this also tells that the radius of hemisphere is 7/2. We can keep this value as it is, or if you want you can take the decimal parts also. So 3.5. Okay. Now coming to the surface area of this solid, let's look at the diagram. What surfaces is available to touch this solid is going to comprise for its total surface area. Okay. How many surfaces available that we can touch? That is the total surface area of this solid. So this face is available, this face is available, front face, back face, bottom face is available. Now coming to the top face, we can touch only this part. Okay, we can touch over here, we can touch here, but we cannot touch inside this sphere. Okay, hemisphere. So the circular region has to be subtracted. Okay, now what I have done is surface area of hemisphere. I have calculated the surface area of hemisphere. So these are the arrows indicating towards the faces. They are available and I can touch the surface of hemisphere, but I cannot touch the circular disc inside the hemisphere. So I have to find the curved surface area of hemisphere. Okay, so curved surface area of hemisphere is 2 pi r square. Okay, so simplify this, it is coming 77 centimeter square. This we need. Okay, total surface area of cube is 6 times side square, so 294 centimeter square. But observe that this black disc is not available in the total surface area of the object. Okay, so I have to subtract this from total surface area of cube. Okay, I hope this is clear to everyone. Otherwise everything has to be added. What we have to add? Total surface area of cube plus CSA of hemisphere. Now we have to subtract one thing. Subtract what? Area of that black circular disc, that is pi r square. So we need to subtract the area of circular disc from the TSA of cube. So area of circular region is pi r square. This much total surface area is 77. That is the CSA of hemisphere. This is the total surface area of cube, and one which is with negative sign is the area of circular disc. I hope this is also clear. Fifth question. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube, determine the surface area of remaining solid. Okay. Now here the edge is L, and there is a depression of hemispherical depression which is touching to the edges of the top face. Now what is being removed is the volume of hemisphere is removed. Okay, so we have removed what volume of wood? The volume of wood removed is equal to the volume of hemisphere. Okay, now we are not dealing with volume over here. So what is gone is volume, but what is being added over here? Once the volume is gone, this much area is available for to be added in the surface area of the complete solid. Okay, once the volume is gone, this much area is available. We can touch, we can put our hand inside this. Okay, so what's the idea? The total, so we will find total surface area of cube. Okay, then we will subtract, so the top layer of the circular disc, the top edge, from the top edge we have subtracted the circular disc pi r square, and we have to add this curved surface region which is available for touching. Okay, so 2 pi r square. This is the same formula in the from the previous question. Okay, I hope the explanation is clear to everyone. What I have to do is I will find the total surface area of cube, then the top edge from the top face. What is gone? A circular area is missing. Okay, this is the flat surface which is missing, but there is a depression. Okay, like this curved surface, like a bowl area is present there. So we have to add the curved surface area of hemisphere, but the circular lid is absent. Okay, I hope this is clear. Okay, given the diameter of a hemisphere is L units, the radius is L by 2, surface area of hemisphere is 2 pi r square. Why? Okay, so we need the surface area of, this is my curved surface area of hemisphere, which we have to add. Okay, so instead of 2 we have 2 pi as it is, instead of r it is L by 2 whole square. Okay, after simplification, so this is 4, this is cancelled with, this is 4 cancelled with 2, we get pi L square upon 2. This is the surface area of, curved surface area of hemisphere. Now total surface area of cube is 6 side square, so 6L square. Now what is absent over here? The flat circular disc is missing, but a curved depression is present. Okay, this lid is gone. Okay, this is pi r square, that's why I am subtracting it. So area of circular disc pi r square, which is coming this. Now area of hemisphere plus total surface area of cube minus area of disc. This is what I have written, and after simplifying this, taking LCM, you get the value. This is the area of solid in form of pi. So I hope this is clear. This is the last question from this exercise, which I have left as do it yourself. So, but still I have given a small explanation for this. What we have to find? We have to find the surface area of this object. What is this object? Capsule. Okay. So this capsule's total surface area is curved surface area of this hemisphere, and the same hemisphere is on this side also. So we will find the curved surface area of one hemisphere multiplied by 2. Then we have to add this surface area, which is called curved CSA of cylinder. So we will be adding 2 pi r h. So 2 times surface area of hemisphere plus CSA of CSA of cylinder. So 2 into, what is surface? Curved surface area of hemisphere. It is 2 pi r square plus 2 pi r h. So this is 4. What common thing I can take it out? 2 pi and 1 r. So 2 pi r, 1 2 is there, r is there, and h is there. So just put the values over here. You will get 220 mm square. Oh, sorry, this is not the last question. This is just have left as DIY question. How many questions do we have? 8. 9 questions we have. Okay. So 7th question. A tent is in the shape of cylinder surmounted by a conical top. If the height and diameter of a cylindrical part is 2.5 meter and 4 meter respectively, height is 2.1 meter and diameter is 4, so radius is 2 centimeter. Okay, and the slant height is 2.8 meters. Find the area of canvas used for making the tent. So this is the first part of the question. In this question, we have to find how much canvas we need to make such type of tent. Okay, so canvas is being put on the CSA of cone and CSA of cylinder. Okay. So what are the given things? Slant height of a cone is given, diameter is 4, height is this, and the rate of canvas is 500 rupees per meter square. The other targets, we have to find the total area of canvas and the cost of the canvas. So base radius is d upon 2, so 2, so 4 upon 2, so 2 meter is the base radius. CSA of a cone, pi RL, simply put the values, simplify it, you will get 17.6 meter square. CSA of cylinder, put the values, simplify this, multiply them, you will get this, 26.4. Total surface area of tent is just simply add the two values in the box. 44 meter square is the total surface area of the tent. Now we have to find the cost. Cost is equal to, what's the rate? 500 rupees per meter square. So for 1 meter square, we have to pay 500 rupees. But we need 44 meter square. So simply multiply them. 22,000 rupees is the total cost of the canvas we need to make that tent. Now this 8th question is similar to that hemispherical depression, okay? But in this case we have a conical depression, conical cavity. From a solid cylinder whose height is 2.4 centimeter and diameter is 1.4, conical cavity of the same height and same diameter is cut out. Find the total surface area of the remaining solid. Okay. Now again, from this conical object, solid object, what is removed? A conical shape of wooden. Is it wooden solid? No. So this shape is out from this cylindrical object. So volume is gone out. So we have to subtract volume, but we are not dealing with volume over here. Okay. Uh, Once this much volume is gone, so this is empty space. We cannot touch here. Okay. But if we put hand, we can touch these edges or this surface. What is this surface in 3D 3D visualization? This is a conical cavity. This is the curved surface area of cone. Okay. So what I'm saying is, what is subtracted? Volume is subtracted, but surface has been added. Surface has been added. Okay. So this is also a do-it-yourself question, but I have done calculation, not in proper manner, but you can see that. What I have calculated is curved surface area of cylinder. Yes, we can touch on the outer surface area of cylinder, so we need CSA of cylinder, and I can touch to the bottom of this cylinder. The bottom surface is available. Okay, so I have to add pi r square. Now observe that this is gone. There is no top lid. Okay, there is no top lid. So I'm not going to add this. Now what I have to add is the CSA of cone. The CSA of cone plus pi r L. This is the simple logic behind calculating the surface areas. You just need to think how many surfaces are available that we can touch. Okay, if I put hand on the top, hand will fall inside. Okay, there is no surface area, but we can touch to this surface. It's a slant surface. Okay, so what I have written is total surface area of solid is CSA of cylinder, yes we need. CSA of cone, yes we need. And one base circle area, yes. These are the values, add them, you will get 17.6 centimeter square, and in question it is given that to the nearest centimeter square. So the answer is 17.6. By rounding off rule, this 6 is more than 5, so it is going to approximate it towards 18. Okay. Now this 9th question is again similar to that capsule question. Okay. Capsule question, this one. So here we have this circular bulged out, hemispherical bulged out surfaces. And in that question we have a depression, hemispherical depression. In both cases we have to add the hemispherical surface areas. Okay. So we have to just think where we can touch. We can touch to this cylindrical surface. This is called CSA of cylinder. Yes, but once we put hand on the top, our hand will fall inside and it is going to be touching this curved surface area of hemisphere. So we have to add it, okay, to pi r square. Same thing will happen in the bottom. So again 2 pi r square. I hope these questions are clear to everyone. If not, you can ask any doubts in the comment section. This is the 12.1 exercise 10 grade 10 CBSE board. Thank you everyone.